Welcome and thank you for joining. Let's take a look at some practice questions from the one-sided limits lesson. So before we get started, I want to bring to your attention some operations with some special numbers. I'll start off with infinity. So recall that we said that infinity cannot divide itself. So if you have plus minus infinity divided by plus minus infinity, in whichever order we combine these signs in here, that would be undefined. Recall that infinity is not a specific number, so it's an indefinite number, which means that we do not know the size of it, and because we don't know the size of it, we cannot compare one infinity with another. The next operation that was not allowed when we evaluated expressions with infinity was subtracting infinities of the same sign, which means infinity, positive infinity, minus positive infinity. That is undefined as well. And that is again because it is an indefinite number. We don't know the size of it, so we don't know how much a difference is in between them. And same thing can be said about negative infinity, take away negative infinity. So again, we don't know the difference between the two, and we're going to say this is undefined as well. So the next numbers of interest, other numbers of interest are the one-sided numbers. So the one-sided numbers are the numbers to the left or to the right of a number, very close to it, but not exactly equal to it. And the most important ones that we mentioned or we work with are the one-sided zeros. So for one-sided zeros, we're going to say something similar to positive and negative infinity. So we're going to say 0 plus or 0 minus divided by 0 plus or 0 minus is also undefined. And that is because 0 plus or 0 minus is has an indefinite value. We do not know the value of it because if this is number 0 and 0 plus is on the right side of it, we don't know how close 0 plus will be to this 0 in here. So the distance between 0 and 0 plus is very, very, very small or indefinitely small. So similarly, we're going to say that 0 plus subtract 0 plus is also undefined because we don't know the difference between the two. They're both extremely small or indefinitely small, so the gap between the two is undefined. And last one, 0 minus minus 0 minus, so subtracting two one-sided zeros of the same sign will be also undefined, so that doesn't exist. So as you can see here, these are kind of similar to each other, and that makes it easier for us to remember. Now I'm going to bring to your attention one last rule actually about about operating with these special numbers, and that would be infinity, either plus or minus, multiplied by 0, either plus or minus. So if anything is multiplied by 0, even infinity, it will turn into a 0. The side of the 0, so plus or minus, will depend on the signs, so how they will combine, and they will work in the same ordinary way that the signs of integers work. So with this in mind, now we're going to start off with the first example, with the first practice question. We have the limit as x approaches 2 plus of x over x minus 2. So when I estimate limits, the first approach will be direct substitution. And that is because, number one, by direct substitution, we may as well be able to finish or to estimate the limit, right? So and number two, if we find out that for some reason we were unable to estimate it, at least we'll understand why we weren't able to estimate it. So we'll understand what the problem was. And by diagnosing what made the limit undefined, then we can come up with a proper solution or a proper approach to make it defined, okay? To simplify it in such a way that that becomes definite. So 2 plus minus 2 minus 2 would be a close to 0 number, 0 plus. And number 2 divided by 0 plus will give positive infinity. So next we're going to take a look at the limit as x approaches 3 plus, x plus 1, x squared minus 6x plus 9. So in this case, again, I'm going to try direct substitution, see if it works. If it does, I'll be happy. If it doesn't, then I'll have to think of what the problem was and how I can fix it. So as you can see in here, 3 plus to the power of 2, and I'm going to do the operations a little bit faster here. So remember, if you have 3 plus squared, that's a little bit more than 3 squared, will give a little bit more than 9. Now, 6 times 3 plus will give a little bit more than 18, and plus 9 at the end. So here we go, we have 4 plus, and down in the denominator we'll have, so let's check and see what we can combine in here. So we can actually combine the number, a definite number, with a one-sided number very easily. And I choose to combine 9 and 9 plus. We could also do these two as well, but it seems that these two are easier. So the two of them will give an 18 plus, and then we have minus 18 plus. So these two together are right here. So as you can see in here, we ended up with the difference of two one-sided numbers, and we don't know if this difference is going to be 0 plus or 0 minus, more than 0 or less than 0, because we don't know the exact size of them. And there is a huge difference in having a 0 minus or a 0 plus. If I have a 0 plus in here, the answer will be infinity. But if I think that the difference is 0 minus, then I will have to say that limit is negative infinity, so I'm going in opposite direction. So I cannot just make that decision like without being sure. So now we're thinking, what is the problem here? What made this limit indefinite? So obviously, if you cannot define the denominator, you cannot define the entire thing, so it's indefinite. So how can I make it definite? Well, the problem was these two numbers. They can't subtract each other. So the next thing I'm going to think of is what brought the numbers in? So the x. So when you have x in more than one term, that means that, and especially if you are, subtracting two same-sided numbers, then it is difficult to estimate it. So that means that we need to do something about x. So one thing you can think of is factoring out x. But if I factor out x and simplify it, then I would still end up with x terms and one-sided numbers in here. So the approach that we use in this case is what we call the factoring technique. Because one-sided numbers are easy to factor or to multiply each other, or can multiply easily, then we are going to factor the denominator and see how it goes. So we're going to rewrite here the limit as x approaches 3 plus. The numerator has nothing that we can factor, so x plus 1. And denominator is x minus 3 times x minus 3. So that would be the, I think we're ready now to substitute. So that is the limit as x approaches 3 plus, and we have 3 plus in here and 3 plus in here, so we'll substitute. So 3 plus plus 1 over 3 plus minus 3 times 3 plus minus 3. So that would make 4 plus. And let's take a look at what we obtain in here. So the difference between 3 plus and 3 is 0 plus. So 0 plus it is. And multiplying here, 3 plus minus 3, that's a 3 plus. So two 0 pluses can multiply. So we know it's going to give a number close to 0 and positive. And 4 over 0 plus is infinity. So therefore, we're going to say the limit equals infinity. So what helped in this case is breaking down the spots where x was located. So instead of having multiple x terms subtracting, we wrote it in factored form so that we have an x term subtract a constant, right? So that they can operate together. So we're going to use this strategy in the next example as well, where we are approaching this time x from x equals negative 3 from the left-hand side of this function. So I will rewrite the limit as x approaches negative 3 from the left. And here we have negative 3 plus 2. I'll factor first, sorry. So x plus 2. And down in the denominator, we have x plus 3, x plus 3. So substitute now. We have negative 3 plus 2. In the denominator, we have negative 3 plus 3 times negative 3 plus 3. Negative 3 plus 2. Now remember that this would be negative 3 from the left-hand side. So you can imagine the number negative 3.0001. So that would be negative 1. And it will be on the left side of negative 1. But the point is that this will be a constant negative number, a negative constant, right? And negative 3 minus plus 3 would be negative 3.0001 plus 3. So that's a 0 minus, multiplying a 0 minus again. So we have a negative number in the numerator. The two 0 minuses will give a 0 plus, and a negative constant divided by 0 plus will give negative infinity. So the limit will be negative infinity. So let's move on to the next question. So as you can see here, and I want to bring this to your attention, we're not looking for simplifying any of the factors. So the only thing we're trying to do is factor the denominator, because that's where we had zero, one-sided zeros adding or subtracting each other, okay? So with this in mind, we'll continue the next example. So we have x minus 2 here. We'll factor to x plus 2, x plus 2. And that's the limit as x approaches negative 2 from the right. So we'll substitute now negative 2 from the right minus 2. And that will be over negative 2 from the right plus 2, and then negative 2 from the right plus 2. So as you can see here, we have about negative 4 in the numerator. We can discuss the side of it as well, why not? But what matters the most is that we have a negative constant number here. So negative 2 from the right is negative 1.999, which means minus 2 negative 3.999. So that will make it negative 4 plus. And down here we'll have the negative 1.999 plus 2, which is a 0 plus. So we have a 0 plus multiplying 0 plus. And a negative 4 divided by 0 plus will give negative infinity. So let's continue with the rest of the examples. I'm just going to take a look and see if there are examples that seem to be a bit more interesting than others. So I will continue with the next example, which is example number 9 here. So in example number 9, again, I didn't go over these examples. That's a constant. So here you only have one x term. That's a constant, only one x term. So only one-sided number, so it can combine easily with this. Only one-sided number, so they can combine easily. And again here, only one x term, so only one-sided number, so they combine easily. So you can do them on your own. So in question number 9, we have negative x plus 4 over x over 2 plus 1. One is true for x less than 3, and the other for x bigger than or equal to 3. X is approaching 3 from the left-hand side. So if you're approaching 3 from the left-hand side, that we have to choose to work with a function that where 3 from the left exists. As you can see here, this would be a piecewise function. It's made up of two different equations, and each equation exists in specific domains as described. So 3 minus will be in the domain of the first equation. So if you want to find the limit as x approaches 3 minus here of this particular function, we have to use the equation negative x plus 4. So that would be equal to negative 3 minus and then plus 4. Negative 3 minus will be a number such as negative 3.0001, and then you add a 4, that means it's about 1 but less than 1. So that would be positive 1 minus, and that would be the answer to this limit. So if you're approaching negative 1 from the right-hand side, we are in a similar situation here, a piecewise function made of two equations. Now the first one is for less than or equal to negative 1, and then the second is bigger than negative 1. So if you're approaching negative 1 from the right-hand side, that means we have to go with the second equation, because that's where negative 1 is located, okay? So we're going to say that the limit as x approaches negative 1 from the right-hand side will be found by using the second piece again, so that would be equal to negative 1 plus and then minus 1. So that would make a negative 1 plus, so it would be positive 1 plus and then minus 1. And that will give, again, try to imagine the number. On the right side of negative 1, you are at negative 0.999. Take away 1, that's going to be negative 1.999, which will make this a negative 2 on the right-hand side of it. So in a similar way, we discussed the next piecewise one-sided limit. So again, you have a piecewise. The first one here would be in the domain between less than or equal to -2. And the second piece is for x bigger than -2. So if you're finding the limit as x approaches -2 from the left-hand side, then we have to check and see where -2 from the left-hand side is located. So it must be less than -2. So this would be where x equals -2 is located, which means that that would be found by using the first equation. So -x squared minus 8x minus 17. And substitute x by -2. So now this is going to be quite interesting because as you can see in here, we have we are going to end up with one-sided numbers. Let's see by direct substitution what we obtain. So we have -2 minus to the power of 2 minus 8 times -2 minus and then minus 17. So that would give us a minus -2 minus squared, that would be equal to +4. So now remember that this would be -2.00001 and then squared. So that would be +4 and then a plus. And then 8 times 2 would be a 16. Again, try to imagine that you have two negatives. That will give a +16. And remember that this would be -2.00001. So that would give a little bit more than 16. And then minus 17. So 16 minus 4, or we're going to estimate in here 17 and 16. We get a -1. And a -4 will give a -5. Now remember that, yes, these are one-sided numbers, but we can estimate them because they're not approaching or they're not on the same side of the same number. So in this case, we're going to say that the limit would be equal to -5. So in the next video, I will go over some limits with absolute values. I hope you found the instructions useful and going through the examples useful. And thank you for learning with me. Bye for now.